Okay, if you just got done watching the third recording, I lost that problem. So I'll briefly go through how to do this by hand, which you only have to do it for this chapter. In the future, you could always use Excel. First thing we want to do is calculate the mean. We know how to do that, right? 6.2. The second part is take each of these x values and subtract 6.2. 3 minus 6.2 is negative 3.2. 9 minus 6.2 is 2.8, and so on. Then we want to take each of these values and square it. Remember, anytime you square a number, it's going to be positive. So negative 3.2 squared is 10.24. 2.8 squared is 7.84. Negative 2.2 squared is 4.84, and so on. After you get each of these numbers here squared, and after you square it, then you take each of these numbers, then you square it. Then you take each of these numbers after you've squared all these numbers, and you add them up, and you get 26.8. So the standard deviation is the sum of all that. This means right here, the numerator of what's inside the square root is that sum of all the x minus x bar squared, which is 26.8, divided by n. And remember, n is the sample size. In this case, n is 1, 2, 3, 4, 5 units. N minus 1, 5 minus 1 is 4. Okay, so you would do 26.8 divided by 4 first. Okay, so just put it in your calculator. 26.8 divided by 4 equals 6.7. Okay, and then if I were you, I would just take 6.7 or whatever that number is. It could be a real long number. Don't round it or anything. Just take that number that you got right now and take the square root, and you get 2.588, which is 2.59. Okay, and that's your answer. All right. If this were population, this is, remember I mentioned that in last recording if you watched it, this would be 26.8 divided by capital N. So you would go square root of 28.6 divided by 5, because n is 5, the big N would be 5. But this is a sample. I already told you it's sample. And you already see the equation here, n minus 1. If this were population, that's the difference between sample and population. Standard deviation. You divide by n small n minus 1 for a sample, and you divide by capital N for population. Just real quick, I'm not going to go through this. We just did one just like it. See the U, remember I said you'll see the U, that's the population thing for a mean, okay? All right? And the divided by capital N. So this time you would divide by 5 if you were doing this problem and got this problem, okay? You would divide by 5 here instead of 4. And you see the different symbol here for U, okay? And you see the standard deviation symbol for population standard deviation. Okay, this is called a weighted mean. All you have to do is take the number of deliveries times the frequency of each and add them up. That's your numerator. So 2 times 3 plus 4 times 1 plus 6 times 6 plus 8 times 2. And if you do that, you add them up and you get 62. And the total frequency is 12. You would divide by 12, and you do 62 divided by 12, you get 5.1667. Okay, this one, no different. It's the same thing as a weighted mean. 76 times 262 plus 96 times 346 plus 66 times 155, all divided by the total of ninth graders, which is 763. You end up with 63,358 in the numerator, and you get that, and rounded to one decimal place is 83 even. This one, same concepts. 12 plus 58, 70 students. Multiply the number of students times the grade of each, divide by 70, you get 79.9. GPA is the same thing as a weighted mean. Just multiply the average times the credits, divide by the total number of credits, 17. You get 3.03. Okay, go into your course. I'm going to have this embedded into your course as a document. I would print it out if I were you, and just print multiple copies or copy it if several copies, because this exact chart will be used for every problem that you use the empirical rule for. Okay, this will not change. These numbers right here won't change for any problem. However, the information you have down here will change, okay? So in other words, here I'm at the mean. Let's just say I'm doing a problem and I want to evaluate probabilities of selecting a random test score among a bunch of tests. Say there's and in this case, it doesn't even matter how many test scores. Let's just say I grabbed a bunch of test scores, I averaged them up, and the mean was 70, and the standard deviation was 3, okay? All right, so no matter what the mean is, that starts right here at 70, right in the middle, 70. Whatever the standard deviation is, when you add that number, that goes right here. And I'll just bear with me, I'll explain it as I go. It's really not that hard once you get the hang of it. In fact, it's very simple once you get the hang of it. And then if I add another standard deviation, that goes here. So in other words, that says plus one standard deviation higher than the mean is 73, because 70 plus 3 is 73. 2 standard deviations higher than the mean, that's the plus 2 SD there, is 76, okay? And one more is 79, okay? All right, now you do the same thing the other way. I take the mean, always start in the middle with the 70, whatever the mean is. Subtract 1 standard deviation, that goes here, 67. Subtract another standard deviation, it goes here, 64. Subtract one more, that goes in the minus 3 category, okay? Now, your goal is to, now you have all the information you need to answer any question asked, okay? So what if I said, what is the probability that if I randomly select one test score, that it's going to be between 67 and 73, okay? In other words, just what is the probability? I'd have all these test scores, they're all, in a little piece of paper and a hat. What is the probability I pull one out that's between 67 and 73? Well, the probability that it's between 70 and 73 is 34%, okay? The probability that it's between 67 and 73 is also 34%, one higher, one lower, okay? So you're just going to add those up. Add up all the percentages that I ask you, or what the problem asks you in between the two numbers they ask you. In this case, it would be 34 plus 34 would be 68%, okay? And you do that for any question asked. What if I said, what is the probability I grab one of these test scores and it's less than 67? So here's 67, right? And I'll always give you something, at least in this chapter, not in future chapters, okay, of one of these numbers at the bottom. Okay, so less than 67, you would just add up all these. Don't forget the 0.15% at the end. So 13.5 plus 2.35 plus 0.15 equals 16%, okay? So there's a 16% chance I grab a test score that's between 60, that it's less than 67, okay? You could also think of it this way. The probability, if I said less than, if I said less than 70, this thing's not working the way I want to right now. Less than 70 or greater than 70, either one, it's 50%, because right in the middle, 50% this way and 50% this way from the middle, okay? You add those up, obviously. And, between 1 standard deviation and 2 standard deviation is 13.5, both plus and minus. Between 2 and 3 standard deviations is 2.35, both plus and minus. And higher than 3 standard deviations is 0.15%. So that's 0.0015 as a decimal, of course, very, very slim chance. And over here is obviously 0.15% too. So back to my initial question of less than 67. Well, if I know this is 34%, right? And from here to here is 50%. I know the rest of these, I could add them up and I'll get 16%, but I know 50% minus 34% is also 16%. If going back to that same question, less than 67. What if I said greater than 76, okay? Well, I would do the same thing. Here's 76, greater than. Just add up these two percentages. 2.35 plus 0.15 is 2.5% chance of greater than 76, right? So basically, this is the most important thing for anything empirical related. first of all, have this chart handy. Maybe make several copies of this and have them handy. And then every time you do a problem, just grab a fresh one out or use your eraser. I just, I always use pen in math. I know it was taboo back in the day, but anyway, just somehow or another, just find an easy way and convenient way for yourself to, every time you see a problem and you know the mean, you know the standard deviation, and just do all this first, because all the information you need to do any problem that you're asked about is here right in front of you. If you just do all what we did first, start with the mean, add 1, add 2, add 3 standard deviations, subtract 1, subtract 2, subtract 3 standard deviations, and you'll be able to answer any question that they ask you. The last question that they'll ask you is kind of in reverse. Okay, and these will all be the same. Like within 1 standard deviation is 68%. Here's -1 to +1, 68%. Within 2 standard deviations, in other words, between -2 standard deviations and +2 standard deviations, you'll see when you add them up, it's 95%. Okay, and the last one is within 3 standard deviations, which means -3 to +3. If you add all those up, you'll get 99.7. So that is another question they'll ask you, and it's always going to be within 1 standard deviation from the mean, higher and lower, within 2 standard deviations from the mean, higher and lower, and between 3 standard deviations from the mean, higher and lower. 68%, 95%, 99.7%. So if they say 68% of the data falls between what 2 numbers? Well, here's the 68. So your answer would be 67 and 73. Okay. 95% of the data falls between, that's within 2 standard deviations of the mean. So if you add up -2 to +2, you add all those up right there, -2 to +2, I goofed, hold on. Sorry, I circled 1 too many, okay? If I said between -2 and +2, which I was a way to unrecord, so to speak, and go back, but there was okay, if I add those up, that's within 2 standard deviations is 95%. So if I add up this plus this plus this plus this, anyway, within -2 to +2 standard deviations is going to be within 95%. So just go within 2 standard deviations, and your answer would be between 64 and 76, okay? And the last one is within 3 standard deviations from the mean, okay? So basically it would be, get this thing to work right, there we go. If you add up all these, and you don't even have to add them up, I'm just telling you, this one is within 1 standard deviation of the mean, 1 lower, 1 higher, 68%, 95% is within 2 standard deviations from the mean, 2 lower, 2 higher, and this one, 99.7, is between 3%. Within 3 standard deviations of the mean, 3 higher, 3 lower. So you just go to 3 lower, 3 higher, but you could add them up if you want, just to make sure, double check if you feel comfortable. But I'm telling you that -3 to +3 will end up being 99.7. So your answer here would be 61 and 79. Okay. So again, within 1 standard deviation is 68%. That's basically just -1 to +1 standard deviations within the mean. 95% is within 2 standard deviations from the mean, 2 lower, 2 higher. And 99% is within 3 standard deviations of the mean, 3 lower, 3 higher. And that's really all you need to do. You do that for every single empirical world problem you get, and it's very simple. Okay, we have a standard deviation of 41. A mean of 41 and standard deviation of 5. And as I mentioned, go right ahead and, okay, put your mean in here, 41. Add 46, that goes here. Add 51, that goes here. Add 56, that goes here. Add 5, I'm sorry, geez. Add 5 goes here. Subtract 5 goes here. Add 5, add 5, add 5. I'm running out of time. Subtract 5, subtract 5, subtract 5. and the answers you will